Everybody, today I want to take a look at a few examples from section 7.1. These are some inverse trig functions, and I want to take a look at some of the tricks we're going to need to know in order to solve these. So I looked at an example of each of the three main trig functions here for inverse cosine, inverse sine, and inverse tangent. Now remember, for each of these, and let's just kind of do a quick, brief review of how these inverses work. So for the inverse cosine, or for all of them, really, we're switching around the angle and the value. So the inverse cosine takes a look at the value and then it shoots you back an angle. So for example, the inverse cosine of -1/2 is going to shoot you back an angle. It's going to say the inverse cosine of -1/2 is going to tell you the angle associated with -1/2. And remember, cosine is associated with the x values, and for -1/2 we have an x value here at 2 pi over 3 and at 4 pi over 3. And it doesn't really know which one of these angles to give you back because there's two of them, right? There's 2 pi over 3 and 4 pi over 3. So for inverse trig functions, we've had to set a domain. We've had to make these one-to-one functions by creating a domain of just half the circle. So for the cosine, we've just used the top half of the circle from 0 to pi or 0 to 180, depending on whether we're talking about radians or degrees. And for the sine and the tangent, we've just looked at the right half of the circle from -pi over 2 to pi over 2, or from -180 to +180, depending on whether we're talking about radians or degrees once again. So we have to restrict our domain to those values. So in order for us to solve these values need to be in that domain, or we're not going to be able to use the fact that we're just using the inverse of the kind of the same thing to just shoot that value out. So if these values here are in the domain, then the inverse cosine of the cosine is just going to be that value. And then we can, for example, if this value here is in our domain of the inverse cosine function, then this is just going to equal -11 pi over 6. We just need to make sure that this is in our domain. So where is -11 pi over 6? So it's definitely not between 0 and 2 pi. So let's go ahead and pull up our calculator and kind of get a good idea where that is. So if I add 2 pi to that, because that'll be a coterminal angle, so -11 over 6 plus 2, and see what direction that's heading, and then let's convert that back to a fraction. That's going to be the same angle as pi over 6. And pi over 6 is in our domain. That is between 0 and pi. So because, remember, the domain for cosine is between 0 and pi, because that is in our domain, that is good. So our answer for this is just going to be pi over 6. All right, because -11 pi over 6 points in that direction, so we can use that angle. Now, if that did not work, we would have to use the other angle, and we're going to look at that in just a second here. Because remember, there's always two separate pointing angles for every single value here, or for almost everyone, except for the ones that point in the 0 and 1 directions. All right. For this next one here, let's look at this one, 10 pi over 7. Now remember, this is for the cosine. For the sine, we are looking between -pi over 2 and +pi over 2. And this is 10 pi over 7. So let's look in our calculator real quick here. And the easiest way to do this is, let's look at pi over 2. So second pi divided by 2. Oops, wrong button. Second pi divided by 2. So we're looking for values between negative 1.57 and positive 1.57. Now let's look at 10 pi divided by 7. 10 pi divided by 7, and see if that falls within those values. That does not. That falls far outside of our values. So this is not in our domain, which means that we can't just cancel out the inverse sign with the sign in order to put 10 pi over 7. But, however, 10 pi over 7 is still less than 2 pi, so it's still in standard position here, which means that we're going to have to use an angle that points in a different direction, because 10 pi over 7 is still somewhere here. Let's see where 10 pi over 7 would lie. That's going to be, because 14 pi over 7 would be 2 pi. So it's probably going to lie somewhere here in this fourth quadrant. So one thing that we can do with the sine function here in order to find a new angle that works is we can subtract this angle here from pi in order to get another angle that's going to give us the same value back. So if I take pi, which is the same thing as 10 pi over 10, and subtract, 7 pi over 7, so this is what I'm going to do here. I'm going to take pi, which is, I'm just going to make it 7 pi over 7, and subtract that 10 pi over 7. This is going to give me negative 3 pi over 7. And this is just a method to find an angle pointing in a different direction that's going to give us an angle that's going to have the same value as this sine function here. So let's see what that means. That means, for example, if you notice that pi over 6 has the 1/2 here, and 5 pi over 6 also has 1/2 here as well, right? And how, if you have pi over 6, how can we get 5 pi over 6? We can just take pi and subtract the pi over 6 to get our 5 pi over 6, right? And the same thing with pi over 4. If we have pi over 4, the sine of pi over 4 is the square root of 2 over 2. We can take pi, subtract that pi over 4, and we get 3 pi over 4, and that's also going to give us root 2 over 2. If you look at pi over 3, the sine of pi over 3 is root 3 over 2. If we take pi and we subtract pi over 3, we're going to get 2 pi over 3, and the sine of 2 pi over 3 is also root 3 over 2. So we have this, and I know that doesn't prove it, but we have this formula that if we have the sine of an angle, it'll give us a value. We can also take pi minus that angle and look at the sine of that angle, and that'll give us the same value. So that's what I'm doing. I'm taking pi minus that angle and looking at this one, negative 3 pi over 7, and that'll give us the same value. Now I'm going to look at negative 3 pi over 7 in my calculator and make sure that's between negative 1.57 and positive 1.57. So negative 3 pi divided by 7, and that is negative 1.34, so that is larger than negative 1.57, so that is within my domain there, so that is good. So this answer here is just going to be negative 3 pi over 7. So the difference between these two is here I was able to use a coterminal angle, an angle that was pointing in the same direction. I just had to add 2 pi to get a coterminal angle, but I was still able to use an angle pointing in the same direction. Here, I actually had to use an angle pointing in a completely different direction, just one that gave me the same value. Because remember, for most angles, or most angles, we have 2 angles that are going to give us duplicate values on our unit circle. And then for tangent here, tangent has a nice little property too, that it kind of repeats every half of a circle. So if it doesn't work for one value, you can just add a pi to it or subtract pi to it and do it again. And this is for sine. And our domain for tangent is also negative pi over 2 to positive pi over 2. So if you notice here, for example, tangent is y divided by x. So if you look, like for example, the angle 4 pi over 3, you have 1/2 divided by, or excuse me, negative 1/2 divided by negative root 3 over 2. And if you look a half a circle away, you have positive 1/2 divided by positive root 3 over 2. And that's going to give you the same exact tangent value. And you can kind of do that for every single opposite angle 180 degrees. All right, so what does that mean? That means that negative 3 pi over 4 is not in our domain here. I can verify that by going to my calculator and doing negative 3 pi divided by 4 and seeing that that is outside of my range, because I can only go as low as negative 1.57, and that's already at negative 2.35. So I'm going to add a pi to that negative 3 pi over 4, and that's going to put me up to pi over 4. So let's do that down here. So negative 3 pi over 4 plus pi, which is plus 4 pi over 4, and that's going to equal pi over 4. And I'm going to check pi over 4 just to make sure that that is in my domain here. So second pi divided by 4. It should be less than 1.57, and it sure is, so that is in my domain. So this would simply just be equal to pi over 4. And that's it. That's it. So I kind of gave you 3 complicated ones. Now what if you had, just from the beginning, the inverse tangent of the tangent of pi over 4, then you're already in your domain, and then your answer would just be pi over 4. These are all just ones that we have to change up before we can give the answer here. I know these are a little bit tricky, so if you have any questions, please post them in the forums and shoot me an email. And I hope you have a great rest of your week. Thanks.